In question number 1, the stated values are distance and speed. These two values are given, and what we have to find? We have to find the mass of the black hole. So what we will do for this is we will simply write down the given data, which is r is equal to 5.34 into 10 to the power 17 meter. Then velocity is 7.5 into 10 to the power 5. Then we have to find the mass, which is question mark. We know for an object which is orbiting around a massive object, the formula is V is equal to under root g m over r. In this formula, V is the velocity of the object which is in orbit, g is the gravitational constant, or it is the universal gravitational constant, m is the mass of the object, the object around which the other object is orbiting. It is not mass of the object which is orbiting, it is mass of the object around which the other object is orbiting. So we can simply, and then r is the distance from the center of the massive object around which object is orbiting and the object which is orbiting. So this is the distance between them. We can rearrange it, or we can reframe this formula for finding the value of mass m. So first of all, we will take square of both sides, and under root will be cancelled and we will be squared. Then we can rearrange it, or multiply r over here and divide it by g to get the value of m. So now we have this formula in terms of m. Then we can simply put the values of r, v square and v, and then g. As a result, we will get value of mass, and that's it. In question number 2, we are given the orbit radius, which is r. Then we are given the mass of Mars. Then we are given gravitational field, gravitational force, strength of Mars. Okay, we are given gravitational force or strength of Mars, which is basically gravity, or which is another name of gravity. To calculate the speed of Mars and the period of revolution of Mars in terms of Earth year. Okay, first of all, we have to calculate the speed of Mars and the period of revolution of Mars. So let me write the given data. You can figure out the given data. I am not going to repeat this. I underline the data and label the given data, and you can simply put it in the heading of given data. So for this formula, we know that V is equal to under g m over r, and we also know for time period, which is time period is equals to 2 pi r over v. Using these two formula, we can solve, or we can get what is required. For value of v, this is the formula of time period. How much time an object take in an orbit to complete its one rotation. It is 2 pi r because it covers the radius 2 pi r, and the velocity by which it is covering. Basically, s is equal to vt. So s is equal to vt, and we are taking the complete round trip. So t is capital T, and s is equal to 2 pi r, and then we can divide v over here. So we will get t is equal to 2 pi r by v. So this is the time period which object will take when it will start orbit from a point, and then it will come to that point again after completing its rotation. Or after covering 2 pi r distance by velocity v. So first of all we will put values in the first formula, which is v is equal to under root g m over r, and then we will get then by subbing the values, then we can get the result which is given over here. After this we can simply get the time period by using this formula, which is t is equal to 2 pi r by v, and when we will put value then get the result, this will be that amount of seconds. So to convert second into year, what we have to do is we have to follow the following conversion. Basically 1 minute, in 1 minute we have 60 second, so 60 second can be cancelled with these seconds, and then we have 1 by 60 minute. So in 1 minute we have, in 60 minute we have 1 hour, so these minutes can be cancelled by these minutes, and we get it converted in terms of hours. Then we have in terms of days, then we have 365 days in a year, so we can cancel the days with this one, and then it will be converted into years. So at the end we are going to basically divide this value with 60 times 60 times 24 times 365, and we will get our required answer in terms of years. That is the solution for part 2. Now moving to part number 3. Okay, question number 3 is not assigned in homework, so we are going to solve question number 4. Over here moon is very close to the sun. It is just 25 meters above the sun, and then we have to calculate what we have to calculate. Determine the speed of the satellite. Okay, we have to calculate the speed, and that's it. We have to calculate the speed of moon when it is orbiting around the sun, and we also know that the mass of the sun is 2 into 10 raised to the power 30 kilogram. So we will put these values in to the solution. It is given data is written over here. In terms of given data, we have radius of moon as this one. The distance from the surface of sun is 25 meter, and the mass of the moon is this one. These three given data are asked us to find from the given appendix, or we should know these three things, three values to solve this one. Over here D will become part of this formula. Let me explain. V is equal to under root g m over r. R over here is not the radius, it is the distance between two objects, because distance is 1.74 into 10 to the power 6 meter, and then there is a distance from the surface of the earth to the surface of the moon to the moon, and which is 25 meter. So we have to add this 25 into the radius of moon. So as a result, r moon plus d distance will become total distance. Then yes, but this 25 meter is very nominal. It will not add anything, or it will not subtract anything. It will not change a value in up to the significant figure we are working with, but it is how we are going to put in formula. R equal to r moon plus t. So Vs is equal to under root g m over r plus d. Then we will simply sub the values and get our required answer. To the middle of the other object. To the middle of the other object.